Hello guys. Today's lab is about Bezier curves and how we can plot irregular shapes on the screen. And so I've used a Pygame again for it. And Bezier curves are basically how exactly the algorithm goes is you have a set of lines with a few set of control points. Okay. Now these control points, they control the flow of the curve, and these control points are given into the Bezier function. The Bezier function, what it does, it takes uh, a matrix, say A matrix, B matrix, and C matrix. Now B matrix is your main Bezier matrix. The A matrix has a parameter T, where the matrix has T square T cube, and T is basically T is iterated till the curve is formed. So T is between 0 to 1, and we can set the values accordingly how we wish for the screen to fill. That is, either we can iterate it with 0.1 or 0.01, preferably 0.005 or something like that. Okay, and then the curve forms, and yeah, the B is the Bezier matrix. That is a standard Bezier curve matrix, and the last matrix, it is the matrix containing all the x coordinates for the final x coordinate and all the y coordinates for the corresponding y coordinate. And yeah, so on the curve is plotted, and yeah, I've basically modeled a simple flower vase kind of a vase over there, and then I've used Desmos to basically find out various control points, and I've basically drawn a graph, and then drawn a sketch, and then I've plotted it, and I'll explain the code in in just a moment, and I'm also going to show the output. So yeah, let's get to that. So here's my code for the plotting of the curve, and it's written in Python, and I've used Pygames for the display and plotting. I have imported system, Pygame, and all the other imports I've used. And here's the matrix multiplication function. So it basically takes in two matrices and it just returns the result over here. And yeah, so here is the function which actually plots each and every curve I have plot like I have made the in the diagram, and so it takes in two matrices, one for the x coordinates and one for the y coordinates, and so this x coordinates this cx is basically a set of four x coordinates and cy a set of four y coordinates. And yeah, so this is the Bezier matrix over here, the um, general matrix which basically plots the curve. And here's the code for how the t is iterated till it's less than 1, and I've set the a values of t cube, t squared, t, and 1. And then yeah, I multiplied all the matrices a into b, and then so on and so forth, and then I have plotted each and every pixel. So in this particular programming language, in Python Pygame, each pixel is plotted through gfx draw dot pixel. The screen where you want to plot it, the x coordinate, the y coordinate, and the color of the plot. So this is what is done over here, and t is iterated over here with 0.005. And yeah, so pygame.init, this is initializing the screen. Screen is basically setting the screen, and I have put it to 640 by 480. And this is the color of the screen, just in case I might use it later. Yeah, so over here, yeah, so I've basically defined cx, cy. I'll just run the code and show you so that I can explain this part. Yeah. So yeah, so this is the diagram which you get, like this is the figure you get when you run the code. Yeah, so the left neck, excuse me for a minute. Yeah, so the left neck, this which is this part, this is the control points for it, these two, cx and cy. And yeah, so this is the call for the function, and this gets plotted. The right neck is plotted using this. The top, this part is plotted using this. And yeah, basically I found the control points for each and every part, and I have basically made this, and this goes on till here. All the bottom, the right body, left body, everything is plotted, and then this displays it on the screen. And yeah, this is for the interrupt, which is like basically if I just want to close it, I can close it like this. Yeah, I shall run it again. Yeah, it's back here. So yeah, so this is how the code is. I basically use matrix multiplication. Using simple matrix multiplication, we can plot any, pretty much every curve we want. So yeah, that's it for the lab. Thank you guys.